All right, we're in AP Calculus. Let's go ahead and actually switch here to my document. Today's date is Thursday, August 27th, 8/27, 2020. We're doing limits to infinity and horizontal asymptotes. And you guys might have heard about limits to infinity before by, I don't know, Toy Story 1, 2, all of those. And where is he? Ah, there he is. Limits to infinity. We're going to finally talk about Buzz Lightyear. And beyond, right? Okay, objective for today. Who has yet to read it? Teflon, have you read the objective yet? You should do it. Go for it.
Use top-bottom rules to find limits to infinity and find vertical and horizontal asymptotes.
There it is. All right, so those all sound like gibberish to us until I talk about what's going on. So our main goal today is, can we graph this function? F of x is equal to x squared minus 1 all over x squared minus 2x minus 3. Everything should fit on this graph that I want to talk about. Here we go. And in order to do that, we need to find the vertical asymptotes. We need to find the horizontal asymptotes. I think eventually we find like some holes and stuff too in this graph. But it should prepare us pretty well for the homework tonight, unlike last night where I didn't do any trig. So vertical asymptotes, I'm going to abbreviate that with VA, and you can do that from now on too, because asymptotes is kind of hard to say. So let's find the VAs. How do we do that? A reminder, VA is where what is set equals to 0. Is that the numerator or denominator? What makes sense that if this goes to 0, then it goes and shoots to infinity? Does the numerator going to 0 or the denominator going to 0 make more sense for a vertical asymptote? Who's got it with a quiet raised hand? You got a 50-50 shot, guys. I know that you're all frantically writing it down too. It's where what is set equal to 0, the numerator or denominator. No? All right, well, let's go with Fiona. What was your guess? Numerator, denominator set equal to 0 that makes this shoot off into infinity.
Numerator.
Ah, close. When the numerator is 0, it shoots to 0. So it's going to be the denominator. Another way of thinking about that is 0 divided by 1, 0 divided by 5, is all of those are 0. But if you do anything like 1 divided by something really, really close to 0, like 1 divided by 0.0000001, it's a really, really big number. So, yep, so we're going to say denominator set that equal to 0, that will find the VAs. And this is a definition that we now need to memorize. Whenever it's asking where are the VAs or anything like that, it doesn't happen that often, but it does help when you're trying to graph these things. Set the denominator equal to 0. Well, if we set the denominator equal to 0, that's awesome, but we're going to have some things that cancel out in here, so we have to be careful. So with this function, let's go ahead and try to factor everything to see what's happening here. I need some help though. How am I going to factor that numerator? The denominator is a little bit easier, you know how to do those, but how am I going to factor that numerator? What are you guys seeing? The x squared minus 1. Any ideas on how to approach this guy? Are you going to use a ninja star, or are you going to just use a trick? Yeah, Fiona again.
Isn't it x minus 1 times x plus 1?
Yes, x minus 1, x plus 1. Do you remember what that guy is called?
No.
That's okay. It's called a difference of squares. And yeah, it's just x plus 1, x minus 1. And if I had like x squared minus 25, it would be x plus 5, x minus 5, because both of these are squares, and there's a difference of squares because there's a minus sign. Perfect. And what about the denominator? What am I going to do to factor that? I'm just going to either be Teflon or Andrea to answer this one. Call on Fiona twice in a row now. Go for it, Andrea. Oh, I clicked it at the same time you did. Yeah, so how am I going to set that up?
It would be -3 at the bottom or at the top? At the top.
It doesn't matter. Just know that -3 is being multiplied, -2 is being added, and what two numbers add to -2 and multiply to -3?
add to -2 and multiply to -3 would be -3 and 1.
-3 and 1, yeah, there it is. So we'll say down here, x minus 3 and x plus 1. Cool, yeah, so whenever you see any sort of fraction called rational functions, whenever you see a rational function, try to factor it. It will help a lot. All right, so we see some things that we can immediately cross out. I see an x plus 1 and x plus 1, shoink, shoink, you're gone. Whenever you have that as a review from Algebra 2, that means you have a whole. So I'm gonna say this is a whole because you can cross out the top and the bottom. And there's nothing left over. If there's still an x plus 1 in the top, then it would be a 0. And if there's still an x plus 1 in the bottom, it would still be a VA. Actually, would it be a whole on top? Oh no, it wouldn't be a whole. So if it was in the top, then it would have a hole still. And if it was in the bottom, it would be overridden and turn into a vertical asymptote. Not super important, but know that if it's crossed out, nothing's left over, it is a hole. All right, and okay, I'm coming back to our definition of vertical asymptote. The denominator, set that equal to 0. The only thing that's left over is this x minus 3. We're going to set x minus 3 equal to 0. So we come down here and say, okay, x minus, what am I saying? X minus 3, set that equal to 0. And Teflon, the vertical asymptote is that x is equal to
3.
3. Yeah, perfect. So I'm going to come up here on the graph, and we're going to make like kind of this invisible wall type of thing. I should make it a dashed line. Do I have the power to do that in this program? No. Okay, so I'm just going to make it a solid line because I'm lazy. But boom. There is our vertical asymptote. Vertical meaning going up and down. Horizontal would be left and right. So it's a vertical asymptote, which means I get closer and closer to that line without actually touching it. And we don't know if I'm like getting closer and closer going, oop, why did I change that to yellow? There it goes. I don't know if I'm getting closer and closer going up, going down, going up, going down. I don't know what direction I'm going. I know that somewhere I'm getting closer and closer to that towards infinity, either positive or negative infinity. So all we figured out is the vertical asymptote. We know the whole, this is where stuff just gets canceled out. So I'll just say whole is canceled out. So for example, you have like the top and bottom. Whenever you cross both of them out, shrink, shrink, that means that is your whole. All right, so we'll use the fact that we have a whole at x equals 3, sorry, x equals -1 in this case, right? So we had x plus 1 was a thing that got canceled out, so I can write down the x plus 1. And then we still set this equal to 0 to figure out where that happened, and it's very clear that the whole happens at -1. So remember, I'll kind of circle this to come back to this. At -1, I'll have a whole. Okay, so we've dealt with vertical asymptotes. It's time to deal with horizontal asymptotes, and by far, I don't know, it's like super overpowering. Horizontal asymptotes are much more related to AP calculus, and you talk about them way, way more often. You're more likely to have like 2 actual multiple choice questions on your AP calculus exam about horizontal asymptotes, and basically an average of a half to no questions about vertical asymptotes. So if you have to pay attention to one or the other, pay attention to this one. It is super, super duper important. Here we go. In order to find the horizontal asymptote, I'm going to say this like 7 times today because you need to memorize this. In order to find the horizontal asymptote, you need to take the limit to infinity. So I'm going to say limit, I'm going to write it out in words first. Limit to infinity. You're going to Buzz Lightyear this guy. To find a horizontal asymptote, you need to take the limit to infinity. And we have notation to do that a little bit more efficiently than writing it out as a sentence. We say the limit, L-I-M, as x approaches infinity, which is weird to start talking about infinity, right? We're finally there. We're allowed to do that. We're in calculus. So the limit of, I don't know, what's our function? I guess it's this f of x. I'll say f of x. The limit of f of x as x approaches infinity is going to be some number. We don't know what this is yet. We're going to come back and figure out what that is. But we don't know how to do that. We haven't learned how to take a limit as x approaches infinity. So that's what the backside is. And so I'm going to come back and fill in the rest of these notes on the front side in a second. Let's for me at least, it's the backside. It might be for you just a few spaces down. I need to talk about how do you do this? And they're called the top bottom rules. And again, I make this habit pretty often in AP Calculus, and I told you guys this last year, of making up my own names for things. If you talk about the top bottom rules to someone else when you go to college, they'll give you a very confused look and say, what? It's just a special thing that John Wynne has created, and I agree with it. It just makes it so much easier. Okay, so how does this work? If you take the limit as x approaches either positive infinity or negative infinity, it works for both ways, going all the way to the left, all the way to the right, no matter what sort of infinity. If the top has a higher degree, so I'll make a note here. Top I wrote in all caps, and bottom I wrote in all lowercase. And eventually I switched that to top is lowercase, bottom is uppercase, and then when they're both lowercase, that just means they're the same. The top now has a higher degree than the bottom. The bottom has a lower degree. And then for part 2, the top has a lower degree than the bottom. And then for part 3, the top and bottom have the same degree. And it would be helpful to know what degree even means. So if I am talking, well, does anyone remember what is degree? Yeah, Andrea?
Is it the exponent?
Yeah, the highest exponent that you have, right? So if I have the exponent of 7, that means you have a degree 7 polynomial. Okay, so, and then these are the rules. And I think you guys have seen this last year. I don't remember, but I'll just go for it. If the top has a higher degree, then the answer is, it could be infinity, it could be negative infinity, it really depends. But to stay safe, you can just say it does not exist. So D, N, E. It shoots off either to positive infinity or it shoots off to negative infinity. You can put that in the notes here off to the side. It doesn't, I always put D and E because then you'll always be correct. And that's more formal, but you can also say it shoots off to positive infinity or negative infinity in like realistically on a graph, what's actually happening. But D and E, you'll always get it correct if you say does not exist. And this whole class is about teaching you how do you always get the correct answer? Oh, D and E. Okay, if the bottom has a higher degree though, it goes to 0. Oh no, I'm getting some lag. Why does this always happen? I don't know. There you go. It shoots to 0. I guess I shouldn't say shoot. It really, you reserve the word shoot for infinity. It goes to 0. And then when the top and bottom have the same degree, this is what is going to be solved by a magic fraction. And I'll show you what a magic fraction looks like in a second in example number 3 down here. But I'll give you a sec to write down these 3 examples. All right, so these are examples that directly relate to these. So example 1 goes with rule 1, where the top is bigger than the bottom. You can see that, right? So the degree for the numerator up here is 2, because the degree for just 5x is 1. So the degree of this entire polynomial is 2, and the degree of this polynomial on the bottom is 1. The degree in the numerator is bigger than the degree in the denominator. You guys can all nod your heads and zoom. Yes, I agree. Yep, yep, yep. Okay, so done. The answer is D and E. Okay. Let's do number 2. The answer is obviously 0 because it matches up with number 2 up here. Who can explain why? Why is the denominator a higher degree than the numerator? Fiona, go for it.
Because the bottom is like the biggest exponent is x to the third, and the top is x squared.
Perfect, yep, there it is. All right, and then this one, I'll go ahead and take the reins. So this one, the degree in the numerator and denominator are both 1, because there's a 1 there, a hidden 1 there. So the magic fraction rule states you just take the coefficients of whatever that term with the highest degree is. So the term with the highest degree is 2x. The term with the highest degree is 5x. I'm going to take the coefficient, the number in front of this x, for the numerator and denominator, and just write down that coefficient. So it's going to be 2 over 5. Done. Again, you take the highest degree term in the numerator, the highest degree term in the denominator. Be careful if there's a negative. I really should have boxed the positive 5x, including this. So I should have put that positive in there also, because it might have been a negative, in which case the answer would have been a negative 2/5. So that's how you do a magic fraction. And that's all, that's the end of the notes, but I need to go back and actually use this now for our problem. Again, we're trying to graph that equation up here. We're trying to graph this x squared minus 1 all divided by x squared minus 2x minus 3. So we need to find the horizontal asymptote. We're going to take the limit of this function right here as it goes towards infinity. What is it? You guys have your 3 rules. Check the degree in the top, check the degree in the bottom, the numerator and denominator. Okay, apply one of those 3 rules to it. What is the horizontal asymptote for that function? All right, I'm gonna give it a Teflon and we're gonna work through this together. So Teflon, my first question for you is, what is the degree of the numerator?
Like x squared?
Yeah, so x squared is the highest, the term with the highest degree. The degree is just the exponents, 2,
Okay.
right? So the degree of the numerator is 2. What about the degree of the denominator?
2.
2. So that means that the degree in the numerator and denominator are the same. We're really talking about rule number 3, where we're going to use a magic fraction. And you can take another peek on how we do a magic fraction. We take the highest degree terms, the coefficients of those highest degree terms, and just write those coefficients down. So find the highest degree terms, write down their coefficients, turn it into a fraction. What have you got?
1.
1. There it is. Yeah, because it's 1x squared over 1x squared. 1 divided by 1 is 1. So I come down here and say that the limit of that f of x as x approaches infinity is 1. We now have the horizontal asymptote. It's at y equals 1. Again, horizontal means run left to right. So we can write down 1, and then we can actually come up here and write down, make an invisible line. Again, if this was a dashed line, it would be a little bit more formal. There's our horizontal asymptote, which means, again, I get closer and closer to that without actually touching it. And I know that I have a hole at wherever x is equal to -1, and I'm basically ready to start graphing this thing. It's not too important to know if it goes above or below, because it'll usually give you that type of information. I'll give you a hint, like if you wanted to do this yourself, just go ahead and plug in like 0 into this. You get 0 minus 1, you get a negative on the top, and then you get 0 minus 0 minus 3. I get -1 over -3, so positive 1/3. So positive 1/3 is right about here, and that means I'm having some sort of function. 1/3 is right about there, actually. I have some sort of function that runs down like this. Oh, there's a hole here, so I have to be careful. Runs down, and then, come on, right there, and then there's a hole right here, and it comes down through here, and goes that way forever, getting closer and closer to the horizontal asymptote as I go towards negative infinity, and getting closer and closer to negative infinity for the y coordinate as I approach the x coordinate, negative or positive 3 from the left. And then you have to, again, test the point over here. You can plug in like 4 or something. If you plug in 4, you'll notice that the number is like really big. It's up here somewhere. So you'll have some function that goes like this, just kind of a quick sketch. Good enough for me. Chunk, chunk. And we have graphed this problem, learning about how to do vertical asymptotes, learning how to do horizontal asymptotes. Holes are less important, but still kind of notable to talk about. Noticeable. And then the last thing I want to say, like after we graph this thing, does anyone need me to pause here? Looks like you're all good. The last thing I want to say is this cool fun fact. So if there is a horizontal asymptote, then, and it's maybe a little bit silly to say this, but the limit of that f of x as x approaches positive infinity is the same thing as the limit of f of x as x approaches negative infinity. That means either one of these are going to be a horizontal asymptote. I say that this is silly because I've already defined that down here. It can go to positive or negative infinity for my top bottom rules. So these should be exactly the same. There's only one horizontal asymptote, in other words. You can't have 2 different horizontal asymptotes, a different one for the left, a different one for the right. It's the same one, left and right. Left being negative infinity, right being positive infinity. cool. That's all I have for the notes. I might have gone overboard with how much I wanted you guys to write down, but there it is. Are there questions before we end? Nope. Okay, cool. So we're going to go ahead and start on the homework. That should be up on Khan Academy. We get out of here at 9:20, right? Yeah, so we got like 12 minutes to do homework. You can turn your cameras off for homework. Oh, I forgot to say also, Friday, tomorrow is our first day of me actually verifying that all of your notes with summaries are uploaded to Google Slides. So make sure that you've been doing that. Make sure you have notes 1-1, 1-2, 1-3, all with their summaries, pictures taken on Google Slides by tomorrow. That is when I'm checking it. All right, good luck on the homework. I'm gonna go ahead and mute myself and turn my camera off as well. If you have questions, I'm in here. Don't leave until I dismiss you, please.